Yeah, thank you everyone for being here this morning. Did I remember to put in the outline? Oh, funny disclosure, first of all, for those of you who don't know me and don't know this. So I'm going to be talking about primarily Scopus today, which is an Elsevier product. So I wanted to note at the beginning that my postdoc is actually funded by Elsevier. Elsevier played no role in my hiring process, at least as far as I know. And while I will occasionally meet with Elsevier staff during my postdoc, they have no control over my projects, what I publish, or anything I say here today. I just did want to note that there's that, that they have funded my postdoc. Okay, so here's the outline of what I'm going to be talking about this morning and what we're going to be doing this morning. So first of all, I'm going to give a little bit of background on bibliometrics, how I understand bibliometrics, and some of the uses of bibliometrics. Then, roughly the first hour, although it depends a lot on people's experience and interest, we're going to be looking at the web interface with Scopus and some of the things you can do beyond just like searching for papers with a particular keyword. Then I'm going to editorialize a little bit about the hazards of using citation statistics for things like trying to rank researchers or journals or things like this. And then roughly the second hour, we're actually going to be accessing the API for Scopus to do some more sophisticated things, especially working with very large sets of bibliometric data. Now, both my slides and the R file that we'll use when we get to the API hopefully got circulated in advance with a DSI Git repo. Did that happen?
It should be up on their website.
Okay, cool. So you should be able to both get my slides and follow along. And also when we get to the API section, you'll be able to actually try some of this out yourself. My goal is to not spend 2 hours talking at you this morning. So first, a little bit about what bibliometrics is. Bibliometrics, as I define it, is a quantitative research field that studies the research process, typically using publication metadata. Okay, so bibliometrics we can think of as an empirical research field. It's a quantitative research field, and the data that it's using primarily comes from publication metadata. There are other sources of data that are used by bibliometricians, that is people who work in this field, data related to patents and data related to like social media references to papers are also pretty common. But sort of the core of the field is using publication metadata. And so when we talk about working with bibliometrics data, we're generally talking about publication metadata. And we'll see some examples of what kinds of publication metadata you can get from sources like Scopus when we get to the more practical part. Here's an example from my own work. So a couple of years ago, I spent a year working at the US Environmental Protection Agency. And for one of the projects while I was there, I did this bibliometric analysis of the research that was being done in that research program. So over here on the left-hand side, all of these red dots are 120 to 130 papers written by EPA researchers within this program. And over here on the right-hand side, I've taken those papers and I embedded them in a big citation network of 80,000 papers. And you can kind of see from here that the EPA papers are sort of spread out, not uniformly, but kind of evenly in this larger citation network. And so I use this to argue that the research being done by this research program was being well received and integrated into the larger intellectual community. Bibliometrics can be compared to a wide variety of other fields. Research program evaluation and portfolio analysis are probably the closest comparison, the most common comparison, but we can make connections to a variety of other fields, history, philosophy, and social studies of science. I actually come out of history and social studies of science. That's what my PhD is in. Digital humanities is also highly relevant. A lot of the same tools and methods used in bibliometrics would also be used in digital humanities. Systematic review and meta-analysis tends to be a little more focused on aggregating findings from especially scientific research. But if you're doing something like a systematic review, compiling a list of resources, you will use some of the same tools that we're going to be talking about today. And as we develop methods for computationally extracting information from large sets of papers, systematic review and meta-analysis starts to look a lot more like what happens in bibliometrics. There are also some smaller fields that you may have heard of. Meta research is this program. There's like an institute or something for it at Stanford. That's what the link takes you to. That's sort of responding to concerns about replicability, or really the lack of replicability in a variety of scientific fields. And the science of science policy is also very relevant. Okay, so some sources of bibliometrics data. Scopus and Web of Science are the two largest and the two most widely used in the field. Scopus is, again, an Elsevier product. That's what we're going to be looking at today. Web of Science was owned by Thomson Reuters for many years, but is now owned by a spinoff called Clarivate. But it's basically still the same thing. This paper here at this link is an analysis done in 2016 of the coverage of these two sources, Scopus and Web of Science. The analysis finds that they have pretty similar coverage and pretty good coverage for natural science and engineering fields. Scopus does a little bit better than Web of Science for biomedical research and social science, but both have poor coverage for humanities. Basically, as a field becomes more focused on books and to a certain extent conference proceedings and anthologies, rather than journal articles, both Scopus and Web of Science have more trouble covering those fields well. So they do really well for natural science, engineering, biomedical research, all focused on journals. They do well with quantitative social science fields that focus on journals, so this would be like economics. But when you get into more qualitative social science fields, like say geography or in the humanities, they tend to be less reliable. They also tend to be less reliable for sources published not in English and published outside North America and the EU. Is it not working?
It's not working.
Oh no.
It's okay. That'll still pick you up.
Okay. So I'll just be sure to stand right here. Okay, so Scopus and Web of Science have some limitations, but they are still the standard in this field. Some other sources that you might use depending on what exactly you're interested in doing. So Crossref is the largest, they're called a DOI minter. So when a paper, like a journal article, has a DOI, Crossref is probably the entity responsible for recording that metadata and making sure that the DOI will actually take you to the paper. They actually have an API, which is unrestricted more or less for public use. So you can use this to retrieve metadata attached to DOIs. There's also an R client that makes it a little bit easier to access the API. Although I haven't used this much myself for reasons I can talk about if you're interested. This is definitely an option if you just sort of need like basic metadata for a set of papers. There's also PubMed, which if you're in a biomedical field, you probably know about and use regularly. PubMed actually has an API. It's a little, let's say, unusual because it's actually designed to retrieve gene sequence information, but basically the same API that you would use to retrieve gene sequence information from PubMed is also set up so that you can retrieve journals and journal metadata. This is also unrestricted for public use, but it only has good coverage for biomedical research in this pretty broad sense. Finally, there's Google Scholar, which is very popular for casual use. I use Google Scholar myself when it's like, oh, I need to look up like this citation, and I don't have a DOI. It also includes books and gray literature, so in some sense it has better coverage for the humanities and social science fields, but it has strict rules against using automated scraping, automated data retrieval, and also pretty robust systems to detect that. So you have to do a lot of work, and it might typically violate the user agreement to scrape data from Google Scholar. And unfortunately, you can't see the last bullet point. The metadata in Google Scholar is an absolute mess. You do searches, and it gives you, weird archive preprint versions of papers when what you want is the authoritative paper. It will include weird matches for things that you didn't intend at all, and get a lot of false negatives as well. So I don't recommend Google Scholar for a serious bibliometrics project. Okay, so now let's take a look at the Scopus web interface. So go ahead and, assuming you're connected to the UC Davis network and not behind your own personal VPN, like I was, that caused a delay getting started, go ahead and open up a web browser and just go to scopus.com. And you should see this. How many people have used the basic document search in Scopus? A few people. Okay. Those of you who have used it, have you used the author search, the affiliation search, the advanced search, these other options right here? No. Okay, cool. Let's see, what do I want to say? Okay, so I'll do it this way. So the basic search that comes up is a basic keyword search by default. And you can do some things here to search other fields within Scopus, and you can change a few basic parameters. But what we're more interested in today are the more sophisticated searches that you can do, starting just with this web interface. So if you go to the author search, I'm going to cover these quickly because I want to focus a little bit more on the advanced search, but it's worth mentioning. So the author search lets you do a first name, last name search. You can also narrow things down by affiliation. So we might do, let's say, looking for people whose last name is Eisen, affiliated with something called Davis. And you can see, oh, here we get Jonathan Eisen of UC Davis as our first result.
Quick question about that, Dan.
Yeah.
To say there's a researcher that published some work as a postdoc or as a grad student at a different institution, is it, if you specify the affiliation, is there any like carryover that it recognizes that person trail, or is it just whatever the affiliation was when the paper was published?
So that's actually a great question, directly relevant to this box right here. So the box says, the Scopus author identifier assigns a unique number to groups of documents written by the same author via an algorithm that tries to match authorship. Okay, so they do try to track people across different affiliations. Although I'm going to talk about in a second, these can cause problems sometimes. It can get things wrong. It can get things wrong when people change affiliations. It can get things wrong when people publish comments and editorials. It can get things wrong sometimes when people change their names, for example, because they can get married. It can get things wrong when people publish in new areas. That can also cause difficulties, which I'll actually show you the example right now. So this is a search for Eric Gershwin. I don't know who Eric Gershwin is. I know that he, I assume, is in the med school, and he is the most highly cited person at UC Davis. That's how I picked him out. And you see, you do a search for Eric Gershwin, and first you get, this person wrote about 1,300 documents, is affiliated with UC Davis. And then you see the next hit here is also for Eric Gershwin, who is affiliated with the UC Davis School of Medicine in Sacramento. And Scopus considers this a second person. And then the third is another Eric Gershwin, who is also affiliated with UC Davis. And I'm not quite sure why Scopus has separated these two. But if you do a search and just grab, the top Eric Gershwin here, you could be missing the papers from the other two authors. And it gets even trickier than that. If you look up at the very top, you notice that this says it's showing 3 out of 4 authors. And there's no way to go like, show me the next authors or anything like that down here. What happens is by default, this author search hides profiles that only have one document. So there's another Eric Gershwin here who was or is at Tufts Medical Center in Boston, but only has one paper. And I wouldn't be surprised if you did just a little bit of digging and found that this Eric Gershwin was the same as the Eric Gershwin who's currently at Davis. But you have to know to check this box. Okay, now when you get...
There's also some concept.
Mm-hmm.
So there's 2 different affiliations. UC Davis and UC Davis School of Medicine.
Yes.
So Davis has about 11 or 12 different codes.
I think when I was going through the affiliation search yesterday, it was like 9, but yeah. Yes. It's still way better than Google Scholar because, you've got, what is this? This is probably 99% of the documents are affiliated with one. And usually these things that you get down here are like commentaries and editorials, which you may not care about so much. But yeah, this is, there are trade-offs using an automated system to identify authors. Now, when you encounter something like this, you can actually help the system out. So you can select all of the people you think of are identical, and you go in here to request to merge authors. And this walks you through a sequence of steps where you confirm, yes, these authors are all actually the same person, and then you can actually choose what the name of record should be. So probably Eric Gershwin's name is not Eric E. Gershwin. So you can fix that, and then you probably don't want to do it with 1,300 documents, but if with a smaller number, you can actually review the documents that are going to be included, and then there's a way to submit your changes and put in information, contact information, so you can get an update once these authors have been merged.
As an author yourself, if you notice this for your own profile, is there a way that you can fix it?
Yeah, basically what I just said. Yeah, and actually the system I just showed you assumes that you're the author whose profile is being merged. Like that's the default information they put into the contact form. Yeah. Okay. So that's author search. Are there any questions about this? Is there interest in playing around with this for a few minutes? Or do we want to move on?
I want to see the advanced stuff.
We want to get to the advanced stuff? Yeah.
I'm personally curious like how you would find co-authors. So if you wanted to like export all the co-authors that one author has been affiliated with, where that information lives and how to kind of do it. I've played around a little bit with this, but
yeah. So I think, so the way I would do that would actually be using the API. But we can get some useful elements along the way. So let's say we want to find all the co-authors for this Eric Gershwin person. One thing we are going to want to know down the line is this number right here, this author ID, and I'll zoom in a little bit so you can see where it is. So when you click on the results of the author search, it brings up this profile page. Oh, can actually maybe get the co-authors right there. Or did I click it and it disappeared? Oh, no, it shows up down here. Okay.
Yeah, looks like they're ranked too by document.
The question is, can you export these? Let's see what happens. I don't see a good way to export these results. So for the moment, let's assume that there isn't a way to. And we're going to need this author ID later. Now, if you're doing this for a large set of authors, like I'm working on a project right now where we're going to need to basically do something like this for about 340 authors, you can put these in a spreadsheet, and when we get to accessing the API, you'll be able to do that retrieval automatically. But okay. Were there other questions about the author search, or people want to move on to the advanced stuff? Okay. So there's also an affiliation search that lets you search like Davis, and you can pull up, all the things with Davis in it that show you, oh, UC Davis has like 8 or 9 different affiliations in here. In the advanced search, let us bring up the advanced search here. So the advanced search is highly flexible. Have people used like Boolean searches attached to fields before in other search engines, or do y'all want me to explain how that works? Okay. Okay, that is totally fine. So let's see, let's start with some keyword searches. What's an area of research that you would be interested in? So you might want to find papers on what topic? Groundwater hydrology. Okay. Okay, so as you start typing field names, Scopus will give you these codes that you can use. So let's search titles, abstracts, and keywords for, it was groundwater hydrology, you said? Okay. And let's say you're interested in historical work. Okay, you want to see what people were saying about groundwater hydrology between 1995 and 2005. Okay, so what's going on here? First, we're searching titles, abstracts, and keywords for this exact phrase, groundwater hydrology. If we just wanted groundwater to be in there and hydrology to be in there, we would probably want to separate these into 2 different uses of this title abstract keyword field. And then we're connecting them with an and. Okay, so we want papers that satisfy all of these various criteria. And then we can set the publication year we care about. There's no way to do a greater than or equal to in here, I don't think. So if we want papers from 1995 to 2005, we want them to be published after 1994 and published before 2006. And this gives us 138 documents that result. Okay. Now you can browse through these, and I won't go through, you click on it and it brings up more information about the paper, and there are links you can follow to get the full text and so on. Over on the left-hand side, there are various filters that you can apply. And these can be done both positively and negatively. So let's say, we don't like this paper, water resources research, for whatever reason. We want to exclude that paper. So we can click the box down here and click exclude. Or we only want things published in that journal. We can limit ourselves to that. these will generally have multiple pages, so you can change, the number of results to display and browse through the pages that way. Okay, here on this slide, I have some examples of fields that you may find especially useful. This first group here, so auth is the author name, so you can search for a particular author. Down here, this AUID, that search is using the author ID we found for Eric Gershwin or whoever. Okay. So we'll use this AUID field when we get to the automated script to get results for this particular author. You can search by publication title, publication year, terms in the title, abstract, or keyword, like we just did. You can search by funder. So besides working at EPA, I also spent a year working at the National Science Foundation, and this was kind of useful to us because we could find papers that acknowledged funding from the National Science Foundation, although this only really works well for recent papers that were published by Elsevier. So it missed a lot of things, but it could still be useful for certain purposes. Then the last group here uses numeric identifiers. So affiliations have ID numbers along with authors. If you have ORCID numbers for a group of researchers, you can search by that. You can search papers by their PubMed ID or their DOI. Yeah. Good question. Okay. So an ORCID ID, I will actually go ahead and log in so you can see what my profile looks like. orcid.org. I think this was actually set up by NIH to try to make it easier for NIH to track researchers. The idea is that you create an account at this website, orcid.org, and then they give you this ID number. There's mine. And when you submit a paper to a journal, you can submit your ORCID ID along with that. And then more or less automatically, everything you publish gets linked back to this profile. So because of the journals I published in, not everything accepts my ORCID ID, but I have all of my publications listed here on this profile. And so I actually linked to this on my personal website. Here's where you go to see my list of publications and learn more about my research. And on the other side, we grab this. We can enter this into Scopus. And it didn't like it for some reason. Why did it not like it? It thought this was incorrect. Oh, it has to be in quotes. That's why. And it still didn't like this for some reason. Okay, I'm not sure why this is not working. But what it should do, in theory, is bring up the list of my publications that my ORCID ID has been attached to. Okay. So now, what I was thinking is that I've sort of shown you some basics, given you a brief idea of some of the search fields that are useful in this advanced search. If you go down and to the right here, you can see that there's a long list of potential things that you can search for. If you click on this little eye icon next to field codes, you bring up a long list that tells you exactly what all these things do. And you can also try to search. So if I look for DOI, this tells me which codes I can use to find DOIs. So how about we take 10 or 15 minutes and you all can play around with this. Think of searches that are related to your field, related to your own work, related to trying to discover work related to your work. Try different searches. And then in addition, let's come back here to one that worked. In addition to trying different searches, take a look at the various options up here. Take a look at this Analyze Search Results option, and also take a look at the various things here that highlight when you have some of these search results selected. And I will circulate and answer questions and help you out. And we'll do this for maybe 15 minutes or so. Yeah.
General question.
Yeah.
First. So I'm mostly familiar with when I was doing searches using Web of Science.
Mm-hmm.
And so I just ran a search through both Scopus and Web of Science, and I found about 2,000 on Scopus hits for the same search terms I found on Web of Science. Is there anything that you can comment on just generally about how that they work for their searches, why you might?
Yes.
Why Scopus grabs more, or what I need to pay attention to?
Yeah. So probably what's going on are differences in the inclusion criteria. And I didn't have a chance to look up the Web of Science inclusion criteria. Basically, what kinds of things do Web of Science and Scopus index? If you follow this link, you'll get probably more information than you really want about how Scopus decides what journals to include. And these criteria will be similar between Scopus and Web of Science, but not exactly the same. So probably what you're seeing is, I know Web of Science has, it's somewhat faster about adding new journals. So it can have more in that respect, but Scopus also makes a point of, like, Scopus doesn't care as much about only getting prestigious journals in some sense. And so, like, Web of Science can be sort of faster, but Scopus can be deeper in that sense. And I think that's part of where Scopus has slightly larger coverage than Web of Science in some areas. Good question. Yeah?
Do you know anything about the date range for this? If you're doing historical documents, how far back do you expect Scopus to go?
How far back are you interested in going? Because I have friends who are historians of science who look at, like, 15th, 16th, 17th century science. 1800s? Probably not very good. It will depend a lot on, is the journal still around today, right? So, like, Philosophical Transactions of the Royal Society is still around today. And I believe that journal in particular has done some work going through their back catalog and doing things like optical character recognition to make the text available and attaching DOIs to things that weren't originally published with a DOI. So for things like that, there's a pretty good chance that you would be able to go pretty far back. On the other hand, if you had if you're talking about a journal that ceased to exist sometime in the 20th century, Scopus probably wouldn't go through the trouble of indexing that.
This is a really good place for you to go talk to your librarian.
Yes.
We actually have a whole staff of librarians who actually collect. If it's feasible, they will actually go and get that thing from, completely free of charge. And
What sources?
I have no idea. You actually, it really depends on the exact nature of the problem. But the key thing is actually human resources dedicated on campus. Which is,
yeah, a lot of, so journals that had sort of reasonably wide circulation, but then went out of publication. Their archives were often put on microfilm and widely distributed. And those, it's really convenient to store them on microfilm rather than digitally if no one cares about it. But there are really good workflows for taking stuff from microfilm and making it available digitally when someone says, I'm interested in getting a look at this. So just like a web search isn't necessarily going to turn up like, oh, there's a complete run of this journal, like in the basement. But if you go and talk to the librarian, they may be able to arrange that for you relatively easily.
And the issue with running into is that most of the text we want is available somewhere.
Mm-hmm.
It's just the places that we found that it's available don't have APIs and ways to count the mass.
No, this is like where there's things like the Library of Congress and might have some stuff that
Mhm.
academies, may actually make some of it, but these guys will actually be digital library level and stuff like that. If it's a massive bulk, it may be creative. It's amazing how people will be willing to do.
Mhm.
I was surprised that we had so many people from that stuff.
And if for some reason there is a substantial expense involved, the librarians will probably be able to help you figure out possible sources of funding. So for example, if it's related to chemistry, the Chemical Heritage Society or the Chemical Heritage Foundation. It's one of those. It's Chemical Heritage something. They have surprisingly deep pockets to fund things like this and to fund historical research in general. Other questions, or you just want time to try out this interface on your own and I'll circulate? What you have in metadata is like, we have the DOI, we have the title, maybe we have a little bit more, but we want to get, sort of all of the metadata that are available in Scopus. So after we get our search results, before that, let me show you one other cool thing. Let's say we want to get all of the papers that cite these papers. We want to do a forward citation search. View cited by, that button right there, does exactly that. I have not yet found a way to do this in the API. I've not found a way to do a forward citation search in an API. So going through the web interface is the only way I know of to do that. The other thing you can do is to export these. When this comes up, if you're going to be like taking this and feeding it into, say, an R script, you want the CSV option. So you want to export this as a comma separated value file that you can open up in Excel like I did, or that is easy for R to read. You might try these other formats depending on exactly what you're using. And then this lets you select what metadata you want to try to grab. When you have more than 2,000 documents, the only option is CSV with this citation information column right here, which gives you information you may already have, except for this EID. This is the internal identifier used by Scopus to track papers. And so if you're trying to get more metadata through the API, it's really useful to have this EID. We're going to see that when we get to working with the script here in a minute. But when we're below 2,000 papers, we can also grab some of this other stuff, including like the text of the abstracts, which could be useful if you're building, if you're doing some kind of text mining. You may be able to pull out funding details if it's available, and so on. When you click export here, with a small set like this of 200, it just downloads the CSV automatically. With a larger set, of 2,000 papers or greater, you have to enter your email address, and it will send you a link in your email, usually 5 minutes later or so. So if you have a set of papers that you want to explore using the API, go ahead and export that now. If you don't have a set of papers, or for some reason that takes a while, you should have a file called purej.csv, assuming you have access to the repo. You can use that instead. You'll also want, at this point, to open up the R file, get from scopus.r, and go ahead and run the stuff in the setup section here to make sure that you have the packages we'll be using. And so maybe in like 5 minutes or so, I will run through the slides I have related to the API, and then we can actually spend the remainder of our time using the API with this script. I guess we should check. Does everyone have the repo now, except for like the people who just came in? Everyone has the repo, files are there. Okay. So maybe I will, for the sake of time, I will move through my slides related to the API. In order to use the API, you will want to visit this website, dev.elsevier.com. Both Scopus and Web of Science have an API. When I first started doing bibliometrics projects a little more than 2 years ago, I chose to use the Scopus API basically because this website is really easy to use and provides really nice documentation. And I literally couldn't find documentation for the Web of Science API. When I did eventually find documentation, it's more complex. Using the Web of Science API, you have to construct sort of a relatively complex, not super complex, but relatively complex XML file that you post to the API, and then the API sends you stuff back. The Scopus API, you're basically just constructing a URL. So it's much simpler to work with. I have heard that Web of Science has adopted a simpler API a few months ago, but I haven't had a chance to check on that myself.
But the Web of Science is using SOAP.
Yeah.
So that's all gets hidden from it. So that's all automated. You need software. So,
is it? Okay.
So you don't actually construct the XML. It's a much more elaborate mechanism which actually makes it simpler after the complexity. Some of these have complexity.
Okay.
So, but the only, yeah.
Yeah, I think the last time I looked at the Web of Science API 6 months ago, it was still like you had to manually construct the XML.
No, that's all hidden through SOAP.
Okay.
This whole mechanism, but unfortunately not what they present. But there's clients for most of the languages that actually
are there? Okay.
All that stuff.
Okay.
But it's very confusing when you just look at that page.
Yeah. Okay. So to get started with this, the first thing we have to do is create API keys. So when you click this My API key up in the upper left, you may also need to create an Elsevier account, which you can use just any email and username. This also gives you some useful things with Scopus. But it's not a big deal. They don't send you a lot of spam or anything like that. And then I'm going to, you're not supposed to share your API keys with people, and there's no way for me to, there at this point, unless you've already worked with the API. The label is descriptive. Website URL. So when Elsevier created this, the idea was like you would use this to embed little things in your website that would like, here's a list of all my papers. And that's sort of what they're asking for here. But if you're doing more of a research project, I usually just include like my personal website. And I've never gotten complaints about that. So give it a descriptive label so you know what the key is for. So we could do API demo, DSI ucdavis.edu. The service agreement, one tricky thing with the service agreement buried in here is that there are restrictions on taking the data you get from Elsevier and making it available to the public. So if you're doing this and you intend to do like an open data research project with it, you'll want to contact Elsevier at some point to say, this is what we want to do. How can we make the data available that satisfies you? In my experience, the folks who sort of work with the API are really friendly and helpful. They want people to use their data, so they want to support you if possible. So like work with them and your librarian to figure out an appropriate solution. And then when you've read the service agreement, you can agree with it. I pretty much always also do the text mining provisions, although I haven't really used them. And then, did this not go through? It should go through. You should be able to go back to this My API key, and it will see, here's the string of characters and letters that you need. We won't run into this, but you probably will, so it's useful to have it as a reference. There are limits to the number of queries you can send per week. These seem nice and high, 20,000 queries, 50,000 queries, and so on. But you can run into them quickly if you're doing something, you might start off with a couple hundred authors that give you several thousand papers. And if you need to, for some reason, query them multiple times because you messed up the first time, right? You can run into quota limits. If you need something much larger than this regularly, again, contact the Elsevier people. When I built the citation network with 80,000 nodes, these limits weren't going to work for me. I worked with the librarian and the folks at Elsevier, and they raised my quota to, I think it's 50,000 per week from, let's see, it is, which one was I using? I was using abstract retrieval. So with just a little information about the project I was doing, they raised me from 10,000 a week to 50,000 per week. Other stuff on this site, the API specification tab gives you an enormous amount of detail about how these APIs work. Abstract retrieval is the one we're going to be using because it lets you retrieve metadata for papers that are indexed by Scopus. And here's an enormous amount of information about the kinds of headers you can send, the options that you have in the queries, what the various HTTP responses mean, and so on. This is probably not useful to you when you're getting started, but it's really good to know that it's there as you get more familiar with things. The interactive APIs are, yes?
I'm sorry, just before you get too far ahead.
Yeah.
I missed that last part. How did you get to the page that showed the limits on? I just want that
I eventually had to find it by searching. There used to be a convenient link on the My API keys, but I don't know where it went. I can show you.
I'm glad to hear you say documentation.
I said it's detailed, and it's better than Web of Science.
Yeah, some of these things are so hard.
Yes, yeah.
And so it's API key settings.
Yep.
API.
Yeah.
But there are some really good pages that are not linked directly.
Yes.
Yeah.
Yeah, the documentation of all the fields that you get in the XML, that's in here somewhere. I've gotten it before.
This is where I strongly encourage you, you guys who are here, that you actually work with each other, because you'll uncover, each of you will uncover something.
Yes.
That only
Yeah. This is the thing that I think makes this system really nice to work with. So I'm here in the interactive APIs. Let me go back. In the interactive APIs, retrieval, so search basically runs a search of like Scopus or ScienceDirect or some other Elsevier product. If we have like a list of papers and we want to get metadata for them, or we have a list of authors and we want to get a list of their papers to identify their co-authors, we want the retrieval APIs. I'm going to be focusing here on abstract retrieval because this retrieves metadata for papers from Scopus. But if you want to get co-authors for an author, you would want to use the author retrieval API. And if you go down in here, so let's say we have these EIDs, these electronic IDs that we got from exporting from Scopus. We can get an example. We can interact with the API through this web interface. Set the response content type to XML. So we want XML back rather than JSON. I think XML is a little easier to work with in R because you can use XPath. And try it out to get a sense of what happens here. So this interface takes the values in this form. So we want to search for this paper with this EID, and you can put your API key here. It includes a demo API key automatically, and it generates the HTML that you would use for that query. It also shows you what the response looks like. And depending on your web browser, you can just copy and paste. So where was I? I was back here. So you can copy and paste this URL, paste it in your web browser, and you see this is the XML that you'll get when you access this through R. This makes it really useful for browsing around to find elements that you might be interested in, like here's the text of the abstract. Here's a list of authors. Here's author keywords. There's a bunch of bibliometric information. And if we go down a bit, I think we're in here somewhere. This is actually the contents of the bibliography. You can pull this in through the abstract retrieval API.
Is there an advantage of using the retrieval versus the search or metadata? There's just like 7 APIs here. Yeah,
so the search, what you're going to be passing in, so if you look at the interactive thing there, it'll have a query field rather than this like EID field. So you're putting in a query that will actually look like the Scopus syntax. And if you paste that in, you can actually see like how the HTML gets escaped and stuff. That will return up to 200 results, and it returns sort of basic metadata. So for something like getting all of the authors, I think getting the text of the abstracts or getting the contents of the bibliography, you'll want to use the retrieval API.
So abstracts and titles?
Abstracts, the full author list. So the search will give you the first author, but it won't give you all of the authors. And the text, the contents of the bibliography. that you'll want to use the abstract retrieval API for. And it only gives you 200 at a time. So if you have more than 200 articles you want to retrieve metadata for, you're going to have to break it up into batches of some kind. Yeah. Okay. So let's go back to the R file. We've seen the website. We should have the basics set up in order to use this. So I want to note here in this demo script, I'm using the XML2 package rather than the XML package. That was because of weird namespace behavior. So the XML package interacted with the namespace in the files that the API returns in weird ways that I couldn't understand. And hopefully maybe Duncan and I can sort it out in the future, like before I run this next time. But we didn't have a chance to do it this time. To set up your API key, what I usually do is I have a separate R file that I call something like API-key.r. And in that file, I will have a line that looks like API key equals whatever to assign the value of the API key. And then I'll just source that. Again, Elsevier doesn't like it when you distribute the API keys around. So it's best to keep this in something that doesn't get tracked in your repository. So if your export has gone through, you could load that, or you can just load the demo file that I have here, which contains everything published in PeerJ, 4,000 papers. We pull out the EIDs, and for the sake of time, let's only retrieve 200 of them. Do people want me to walk you all through this, or do you want to try it by yourselves, like working with people sitting next to you? I've included a lot of explanation of what's going on through this script, so I hope it should be accessible, and that could get us away from me talking so much.
Why are we using EID instead of DOI?
Great question. Not everything has a DOI. Everything in Scopus has an EID as well as a Scopus ID. So when you're retrieving stuff from Scopus with the API, you'll want to use one of those two, unless you know that absolutely everything has a DOI.
What's the EID?
Yeah, where is that PeerJ file? Oh, that's not helpful. So the EID is an electronic indicator used by Scopus internally.
Okay.
So when you export that citation information from Scopus, you'll get a CSV file that looks like this. And the last column here will be those EIDs. So in the R script, the first few lines that actually do something, open this file and grab the contents of this column. Now, because this is PeerJ, I think pretty much everything has a DOI. There is something in PeerJ that does not have a DOI. Okay, so that's why we would want to use this EID instead.
If you only have a list of DOIs, then you need to do that search like you did before to then pull up like the search of Scopus to then pull up all the EIDs.
So you could do it like I did here, right, where we put them all together into one giant query. Or just like there's an abstract retrieval endpoint for EID, there's also one for DOI. So you could do that directly. Excuse me, you could follow basically the same method I follow in the R script to retrieve, basically you would put DOI here and you would feed in a list of DOIs.
It'd probably be the same for author search, but you use both ID or
Yep.
some internal
Mhm.
Scopus ID.
Yeah, or if you had the Scopus internal IDs, you would want to use this author ID.
That's the internal Scopus author ID.
Mhm.
Cool.
Yes.
For the abstract retrieval, it doesn't, in that CSV file you have an output, it just give you a list of the authors, and one string of all of them listed. Is there a place within that, within the abstract retrieval, where it gives you the author IDs? The Scopus author IDs?
Yes.
So like find them as well.
So let me see if I have one up here. Should probably close some of these. So one thing that's really nice about this is that you can try searching in the file to see, we want the authors. Where are the authors?
And this is from the abstract.
Yeah, this is the abstract retrieval API.
Yeah.
So what you get right here, this is the first author. This is not what you want. You want all the authors. All of the authors are found down here in this authors node. And the author IDs are tucked in here as this attribute to the distinct author nodes under the authors node.
Which is differentiated from the first node, which is just author.
So the first one is another author node nested inside this DC creator thing. And if you notice the search results over here, there are 360 results for author. You see the results over here, they're kind of on the edge, but there are a lot, and that's because these author nodes also show up down here in the bibliography. So you need to use a bit of XPath to get down here, and I walk you through that in this section. So showing you, we get too many things for author, we can narrow it down with a little bit of XPath. Here's how we extract the author IDs, and here's how we can extract, for example, the surnames of authors. So are people mostly content to work through the R script on their own? Okay, I will circulate in case you have questions.
Thanks, Dan.
Thanks so much.
Yeah.